Hey guys, I'm back, STEM with Sid, and today I'll be going over related rates, which is another application of chain rule, except you are doing variables that that are changing with respect to time. An example we have is like a cone, where you have, let's say you have a tank and the height of the water level is changing. But you know, the height is changing, right? But that would if the height, sorry for my bad drawing of the cone. Um, the height is changing, correct? So let's say this is the height, right? But that also changes the volume, and it doesn't change at a similar rate. Height increases like this, right? Like, oh, height. If you add more water, like the radius is getting bigger, right? The radius is changing per time, when depending on like how you're like, dropping water in. So like the height of the water is changing at a rate of dH dt. This is from a problem set in the calculus textbook I'm using, but the height is changing, let's say, at negative zero point 0.2 feet per minute. We have dH dt. And the radius, they give us dr dt, and that is changing at a rate of negative zero point 0.1 foot per minute. So the radius is increasing negative zero point 0.1 foot per minute, and the height is changing negative zero point 0.2 feet per minute, right? So we have the change in height and we have the change in uh, radius. Now, what is the rate of change of the volume? So it's asking what's dV dt. Now, how do you get dV dt? You can use the equation for volume, and how do these two come in play? Well, you can't find dV dt by itself. You're going to have to do some chain rule in here. And it's saying at a specific height and radius. So dV dt when r is 1 foot and height is 2. I have to do this because they're giving us the r and h, because otherwise you're just going to get a general equation for dV dt, and they want an actual rate at a certain instant when the r is 1 foot and the height is 2 foot. So you would have to you have to use the volume equation. So volume equals pi thirds r squared h, and we're trying to find the derivative of v. Now, first, you would do, so d dt of v equals d dt of pi thirds r squared h, because this is all with time. Then this will equal, so this is just dv dt at this point, and that equals, well, you can use product rule. And pi third will factor out because that's just multiplying. And then we have inside, we have derivative of r squared. So r squared h. Let's leave this as f, and this is, well, x, and this is derivative of g. Or f derivative and then derivative. So f times the derivative of g, so r squared times dh dt, or h prime, just like how we did xy prime for implicit differentiation and chain rule, right? Plus, and the other variable that we're talking about here is time, okay? Plus g times the derivative of f. H times the derivative of f, which is 2r, then r prime, or dr dt. And that is it, pretty much, for the we just used product rule, and then we used chain rule. And to end the problem, you just have to sub the values in for, because dv dt is what we're finding. R equals 1 foot, so put 1 for r. H equals 2 foot, so put 2 for h. dH dt and dr dt, we have those values. We have those values right here. So you can plug in negative 0.2 and negative 0.1 for those. And then you should get your answer. And that's pretty much it for related rates. You can do it for like other scenarios too. I won't do them, but I can show, like, let's say you have water, like a pond, and if you drop a rock, you can see like the ripple effect. If a pebble is dropped, there's concentric circles. Well, let's say they give you the derivative of, let's say they want to know the change in the area per time at a certain radius. Well, they have to give you dr dt. They have to give you how the radius changes. Giving you the radius change, that's not necessarily how the area changes, right? So you can use the formula a equals pi r squared, something that utilizes r in there and area in there, to take the derivative, and then use chain rule with r to find the r. And you can do this for any circumstance. You can do it where you can do it for like an inflating balloon, like the radius of the balloon is increasing. How does that change the volume? Like when you inflate it, you can do this for let's say a ladder. A ladder's hanging on like a wall. The radius or the distance between the walls changing. How does that change the distance, the distance between the bottom and the top of the ladder? You can use Pythagorean theorem basically to relate those. Basically, that's for any change in angle of elevation, right? And then you can also do like a piston. Like if you have the velocity of a piston, the angle inside the crankshaft of the piston, if that changes, if you know the relationship, as long as you know the relationship between like what distance or velocity and theta or if you know any equation, and if something changes in that equation that changes the overall thing but at a different rate, you can use related rates. Just need to know one of the rates and know how to take a derivative, and then you're able to solve related rates problems. Thank you for watching. Hope to see you next time.